Now let me talk about the effects of toxins and mutations on voltage-gated potassium channels. At first I want to talk about the toxins. Dendrotoxins is actually present in the wax. It blocks the voltage-gated potassium channels. Now blocking means it actually blocks the ionic passageway, and by doing this it actually increases the nerve excitability. Now why nerve excitability increases? Because we know that voltage-gated potassium channel is responsible for repolarizations, and repolarization actually reset the action potential. That means at first the neurons was at resting potential at minus 70 millivolt. When depolarization occurs, the memory potential increases and it can reach up to plus 50 millivolt. Then repolarization occurs due to the opening of voltage-gated potassium channels, and then it actually comes about minus 70 millivolt or resting potential. Now if voltage-gated potassium channel is blocked, what will happen? Repolarization will not occur, so the depolarization will continue, and that causes the prolongation of action potential, and that causes the increase in nerve excitability. So another toxin like apamine that is present in bees, it also blocks and performs the same functions. And calyptotoxins, it is one component of scorpion toxins. It also blocks the neurons and actually increases nerve excitability. So it blocks the voltage-gated potassium channels and increases nerve excitability. Now let me talk about some mutations of voltage-gated potassium channels. Like one example is voltage-gated potassium channels 11.1. It is, the gene is called HERG, and it causes long QT syndrome. Now QT indicates the timing of depolarization and repolarization of the ventricles of heart. So when the time increases, we call it long QT syndrome. Now why it occurs? Because this channel do not perform actually work its normal work functions, and it is due to the loss of function of this gene. Now mutant channel opens more slowly. As it opens more slowly, so repolarization actually occurs lately, and that causes prolongation of action potential. In the cardiac muscle, if the action potential prolongs, what happens? The cardiac arrhythmias comes and sudden death can occur. Another example of mutations that occurs in voltage-gated potassium channels is voltage-gated potassium channel 7.2. The gene is called KCN potassium channel Q2 and KV7.3 KCNQ3. It causes, this is also a loss of function mutations. It causes benign familial neonatal convulsion, in short BFNC, and it is due to the neuronal hyperexcitability, like the same function. If it not works, the repolarization will not occur, and the depolarizations continues. That causes prolonged action potential, and that causes neuronal hyperexcitability. Another example is voltage-gated potassium channels 1.1, or the gene is called KCNA1. It causes episodic ataxia type 1. Now ataxia means loss of voluntary movement, motor movement, and in these situations a brief stress-induced attack of neuromuscular coordination occur, and it is also due to the hyperexcitability of the motor neuron.